Hey y'all! So today we're going to be learning about section 7.6, which is about the reduction of air pollutants. The learning objective for today is that you can explain how air pollutants can be reduced at the source. Some of the essential knowledge that you're going to gain is some of the methods for reducing these air pollutants and the some specific like machinery and strategies that exist. So first of all, we're just going to talk about why reducing emissions is important for reducing air pollutants. As we've talked about, a lot of the emissions from the combustion of fossil fuels or emissions from cars release a bunch of air pollutants. And so if we can reduce emissions, we can reduce air pollutants. Some of the ways that we can do that is some individual choices that we can make, such as driving less, walking, biking, or busing more. Conserving electricity, whether that's just doing things like turning off your lights or getting smart appliances that actually use less electricity. Eating more plants and less meat, because there's a lot of emissions that go into the production and transport of meat. And then also advocating for renewable, non-polluting energy sources such as solar, wind, and hydroelectricity. There are some laws and regulations that are going to impact these air pollutants. And the first one is a very important one that you are required to know for the EP test, and that is the Clean Air Act. I've mentioned this before, but just to make sure you understand it, the Clean Air Act is going to allow the EPA, the Environmental Protection Agency, to set acceptable levels for the criteria of air pollutants. They can monitor emission levels from power plants and other facilities, and then they can tax, fine, or even sue corporations that are releasing emissions above the levels. Then we also have the CAFE vehicle standards, and the CAFE stands for Corporate Average Fuel Economy. These standards are going to require the entire US fleet, that's the verbiage that they use, but basically all the vehicles, to meet certain average fuel requirements, so like the miles per gallon that they get. This is going to require vehicle manufacturers to work to make more efficient vehicles because the standards require them to. More efficient vehicles are going to burn less gasoline and therefore is going to reduce less NOx, particulate matter, carbon monoxide, and carbon dioxide, which is not an air pollutant, it's a greenhouse gas, but it's something that can be regulated by these CAFE standards as well. So then we also have pollution credits, and pollution credits are going to make it so that companies that reduce emissions below the EPA level earn pollution credits. Now, pollution credits that these companies hold on to, these companies can sell the credits to other companies that are not below the emission levels. And so it's kind of this like trading where the better companies can sell their credits to the ones that have more emissions, and it can kind of offset those emissions from the EPA's standards for those companies that are below those standards. And so it's kind of a way where you can trade it around to make it so that overall we're doing better, so the EPA finds it's good. But a fun fact is that Tesla, because they are making so many extra cars that are way below these EPA set requirements, they're getting a bunch of pollution credits and they sell them off to other car companies and other companies. And fun fact that Tesla makes most of its profits actually from selling these. They don't make that many profits from their cars, at least at this point. Their main driving force of their profits is the fact that they get to sell off all of their credits. So pollution credits can obviously be a very profitable option for some companies. So some of the things that we want to do is to reduce vehicle air pollutants, and there's a lot of ways that we can do this. And I'm going to highlight a couple technologies that exist. The first is a vapor recovery nozzle, which is going to be something that is used at the gasoline stations. So what this nozzle does is it's going to capture the hydrocarbon VOCs that are released from gasoline fumes while refueling. If you have ever refueled your car at a gasoline station, you're probably aware that it very much smells. And so they are going to use these vapor recovery nozzles in order to capture some of those VOCs. The way that it works is there's a separate tube inside the nozzle that's going to capture the vapors and return them to these underground storage tanks beneath the gas station. So it's going to reduce the amount of VOCs that are getting out into the air. And remember that VOCs contribute to smog and they irritate the respiratory tract. They also, gasoline specifically, has something called benzene that can be released from the vapors, and benzene is a known carcinogen. So this is another one that we can be decreasing by using these vapor recovery nozzles. Now, another thing that can be used is a catalytic converter, and catalytic converters have been required on all vehicles since 1975. So most vehicles out on the road have these. But the way the catalytic converters work is they contain these metals, specifically platinum and palladium, and those bind to the NOx and the carbon monoxide. So the catalytic converter is going to convert the NOx and the carbon monoxide and other hydrocarbons into carbon dioxide, nitrogen gas, oxygen gas, and water. I mean, carbon dioxide is still a greenhouse gas, so it's not the greatest, but it does not have the health implications of these other air pollutants, which is why it's still good to not have it there in the environment. But it's going to be taking all those and then converting it just to water, nitrogen gas, oxygen gas, and carbon dioxide instead of the NOx, carbon monoxide, and other hydrocarbons that are air pollutants. Now, how is it that we can reduce the SOx and the NOx? So the first one, in order to get rid of sulfur dioxide, power plants can use crushed limestone. And so the way that this works is you're going to have the crushed up coal mixed in with limestone before it is burned in the boiler. So then the calcium carbonate in the limestone is going to combine with the sulfur dioxide to produce calcium sulfate, which is not going to be released. Calcium sulfate is going to be like a hard solid, as opposed to sulfur dioxide, which is going into the air. And calcium sulfate is also pretty cool because it can be reused for other things, such as making gypsum wallboard or sheetrock, which is used in building homes. So you can take this and you can actually use it for other purposes so that it's not having these air pollutants going out. And this is kind of a picture of how this works. So again, you're putting the coal and the limestone in so that when it goes in and it's burned, you're going to actually have this whole system that's going to be able to collect that calcium sulfate, and it can be captured to be used for other things, but ultimately it's making it so that the exhaust does not have the sodium dioxide in it. Now, another thing that we have is known as a fluidized bed combustion, and this is used to reduce NOx. So what's going to happen here is you're going to have these jets of air that are pumped into the combustion bed. And what's going to happen is when these jets bring in more oxygen into the reaction, it makes it so that combustion is more efficient, and it's going to cause the sulfur dioxide to have more contact with that calcium carbonate in the limestone. And it also is going to allow the coal to be combusted at lower temperatures, which reduces less NOx. So when you have this crushed limestone combined with these fluidized bed combustion, you're going to be decreasing the SOx and the NOx at the same time in your one coal power plant. Now we're going to look at wet and dry scrubbers. And again, these are going to be more at a plant level. This isn't something you necessarily just have in your house. So dry scrubbers are awesome because they're going to decrease our NOx, our SOx, and our VOCs. And what these are, they're going to be these long column tube pipes that you see right here in this picture. And they're going to be filled with chemicals that absorb or neutralize our oxidants, the NOx, the SOx, and the VOCs, from exhaust streams. So calcium oxide is going to be a really common one that we have in there, and it reacts with sulfur dioxide to form the calcium sulfite. So these chemicals are going to go in, they're going to neutralize all of these air pollutants so that they aren't going to be going and release. So if you see here, you've got this process happening, and then you've got a dry scrubber that's going to be having these chemicals in it that are going to be working to decrease the air pollutants. Now we also have what's known as a wet scrubber, and that is going to help with the NOx, the SOx, the VOCs, and particulate matter. And the way that this works, it can also have chemical agents that neutralize them, just like the dry scrubbers do, but it also includes a mist of water, which is why it's called a wet scrubber. Dry scrubbers don't have this. That's why they're dry. The wet ones have the water. And what it does is it mists what is coming through, and the particulate matter is going to get trapped in with the water droplets. Then these droplets are just going to kind of mist and fall down, and you're going to have all the particulate matter trapped in them. And at the very bottom of this whole setup, you're just going to trap all the polluted water, and you have a whole sludge collection system for it. And so if you have these wet scrubbers, you can be getting the SOx and the NOx and the VOx out with the chemicals that are neutralizing it. And then you can also use the water for the particulate matter. So theoretically, the stuff that is going out the flute at the top is going to have either none or way, way decreased levels of all of these air pollutants. Now, how is it that we can reduce particulate matter? The first thing is going to be using an electrostatic precipitator. And the way that this one works is, again, in power plants and factories, you're going to have your emissions passing through this device that has a negatively charged electrode, which is going to give your particles a negative charge. Negatively charged particles are then going to stick to these positively charged plates that's going to trap them. So you give them a negative charge so they stick to the positive plates, and then they're kind of going to be stuck there. Then every once in a while, you're going to be able to remove those plates, not remove the plates, but remove all of the particles from them. You just kind of run a stream through it. It's going to discharge it. All the particles are going to fall down, and it's going to be collected so that it can be disposed in landfills. Then we also have what's called a baghouse filter, which is going to also help with particulate matter. And this is going to be just like a big fabric bag that's going to trap all the particulate matter as the air from the combustion and the industrial processes passes through it. And so this bag, you can kind of think of it almost like the bags that you have in your vacuum. It's just going to collect everything. Then every once in a while, it just gets shaken out so that all the particles are going to fall down again into this collector where it can be taken to the landfill so that it's not going out into the air. All right, so this is going to be your practice effort cue for 7.6. We're going to practice the skill of using data and evidence to support a potential solution. So what I want you to do is make a claim about the effectiveness of the Obama CAFE standards as an effort to reduce the levels of NOx in urban areas, and then justify your claim with data from Figure 1. So I'm going to explain this a little bit. This graph is going to be showing the miles per gallon that new passenger vehicles are having. These blue lines here are going to represent the Obama standards. There's a few different tiers of the types of cars and their regulations, which is why we have multiple different types of blue lines. But the blue lines are going to be based on the Obama standards of kind of the progress we've made and the theoretical progress that will be made in the future. Now, when Trump was elected, Trump came in and did a freeze on these standards. So the orange lines are going to represent where these miles per gallon, the fuel efficiency is going to be for these cars under the new frozen standards from the Trump administration. So you're kind of looking at like the blue Obama standards versus the black is historically where it's been, and the orange is kind of the predicted with the like non-existent standards under the Trump administration. So you're going to use that to justify the claim that you make about the effectiveness of the Obama standards. So that's going to be your practice effort cue for 7.6. Those are your notes on 7.6.